Hello guys, in this video we'll be dealing with problem solving using equation of motion. So now we just write some formulas down, like we have distance, displacement, speed, velocity, acceleration. So we write those formula, and in this video we'll be deriving the three equations of motion and how to apply them. So now let's start with speed. Speed is what distance over time. So our speed, so from this place, this is our speed, which is what d over t. So to get our distance, the formula, this is the formula for speed measured in what, meter per what second. Time is measured in second, so unit of speed is what, meter per second. And so from this place we can get our formula for distance. Our distance will now be distance d will now be what, cross multiply, we have speed times time, speed multiplied by time. From this, so we have s t. So the SI unit for this is meter and this second. So the unit is what, unit of distance, unit of speed is what meter per second, and unit of time is what, meter. Unit of distance is speed is meter per second, like meter per second, and time is what, second. So applying the law of indices, here we have meter, so we sum up the power, we know that there's one here, so -1 plus 1, that's 0. So we have s by 0, and anything raised to the power of 0 is 1. So we have what, meter as the unit of distance. Now let's move to velocity. V. Velocity is what, displacement covered per unit time. Displacement covered per unit time, that is over time. So displacement, we can represent displacement as, let's use x as represent, and time in what second, time t. So this velocity, so the unit of velocity will now be what, displacement. The difference between displacement and distance is that displacement is the movement of an object in a specified, is the distance in a specified direction, while distance is just the magnitude of an object. So the unit of this displacement here is what, meter, to same as what, distance. So we have meter over unit of time is what, second. So here we have meter per second. So now the unit of speed and unit of velocity, they are the same, and the unit of displacement and the unit of distance, they are the same. This is the unit of velocity, unit of time, unit of speed, meter per second. Also unit of distance is meter, unit of displacement too is what, meter. So here we can get the formula for displacement too, that what, displacement will now be equal to what, x, which is equal to what, velocity times time, v times time. So this formula we can also use it for distance also, since they have the same unit. So, and distance d can also be what, vt, because here we have distance is what, st, so we can use vt. Speed and velocity, they both have the same unit, so we can use speed, we can use time. So this one formula, this another formula for velocity here, and this another formula for speed, or for distance, this is it. So So now let's move to acceleration. Acceleration A equal to what? Change in velocity, change in v by time. The increasing rate of change in velocity, that's acceleration, while deceleration is what? The decreasing rate, and deceleration is also known as what? Negative acceleration or retardation. So for this acceleration, we have what? Final velocity v minus initial velocity u over time. So acceleration is now, so you know velocity is in meter per second, unit of acceleration. Velocity is in meter per second and time is in second. So this, you now have meter s raised by minus 1 minus 1 also. Law of inverse, you have s raised minus 2. This is the unit of acceleration. So now equations of motion. So we'll be deriving the three equations of motion. We have the first equation of motion, we have v equals to what? U plus at. We also have the second one, s as a distance equal to what? Ut plus 1 over 2 at square. We also have the third one, which is v square equals to u square plus 2as. So these three equations of motion will be deriving. So for the first one we can derive it from what? Acceleration, which is equal to v minus u over t. So by cross multiplying, we have what? V minus u equal to at. So now making v the solid formula, we have v equals to what? This u coming to this place, it will be positive, that's what? U plus this 18. That's the first one. This is how we got this equation, first equation of motion. So now we will be moving to the next equation of motion. The next one is just talking about speed. So and we know that it's talking about distance. So we can derive this from average speed. So you know average speed is what? When something's average, that's what we have, n plus n over 2. So you can derive this by saying that what? The final velocity plus the initial velocity over 2. So this is final, this is the average speed. So now we already know that speed is what? Speed is what? Distance over time, right? So we now write distance over time equal to what? What's our final velocity? Recall that this v here is what? U plus at. You insert the value here, u plus at plus this u here, all over 2, right? So from this place now we can collect like times here and say that what? D over t is now equal to what? 2u, u plus u, 2u plus what? 18. So this we have this 2 over 2. These two cancel this. We have d over t equal to what? U plus at. Bringing out, you have 1 over 2 here, because when we multiply 1 times this, we have 80 over 2 here. So now we are getting it. Now we cross multiply. So when we cross multiply, this t will multiply all here. We now have what? Ut plus 1 over 2 a t times t square. So and we know that this d is our distance, and we can also represent it as what? S. So putting s here, we have the equation. That's the second equation of motion, where this u is the initial velocity or initial speed. So the last equation of motion, we can also get it from this average speed. Speed is d over t, so we equate it to this d over t, which is equal to v plus u over 2, which is average speed. So now this d, we bring it down, so equals to, when we cross multiply, no, let's just make this subject formula here. So this one will be what? v plus u over 2, right, times t. So we have d separate there like that. So now we can also cross multiply too. Okay, let's cross multiply. By cross multiplying, we have 2d, right, equals to this. So now you know that from this acceleration we can also make our t the subject formula. Making t the subject formula from this, making our t the subject formula, we have at equal v minus u. So t will now be what? V minus u over what? A. Right? So this value of this t, we substitute it here. So now we now have 2d equals v plus u, to bracket, close bracket, v minus u over a, like this, right? So multiplying this by expansion, we have 2d will now be equals to what? V times this, that's v square. V times this, that's what? Minus uv. U times this plus uv. U minus plus u times this, we have what? Minus u square. So everything over what? A, right? So this we cancel this. When we cross multiply again, we have what? 2ad equals v square minus u square. So, and we want our v square to be the subject formula. So what do? We now say v square will now be equals to what? Well, now because this coming to this place, we have positive u square because of this, so plus 2ad. This is the third equation of motion. You can also change this to s, which is v square equals to u square plus 2as. So this is the derivation. So now we'll be solving question on using the equations of motion. But before the example, let me just give these points we need. So a body starting from rest, when the body is starting from rest, the initial velocity u will be 0, because when the body is in rest, there's no velocity there. So, and the acceleration will be what? Positive. This starting from rest, acceleration will be positive because it is increasing. So a body going to rest, the final velocity will be 0. When it is going to rest, final velocity will be 0 and acceleration will be what? Negative, because it is decreasing. So a body moving with constant velocity, so when the body is moving with constant velocity, like this is the body, this is moving with velocity, no acceleration is like this, and the acceleration is what? Like this. But when it is moving like this, there's no acceleration there. So when a body is moving with constant velocity, acceleration is what? 0. So that's just it. Now we'll now solve question. So now example, we have a train has an initial velocity of 44 meters per second and acceleration of minus 4 meters per second square. Its velocity after 10 seconds is. So first thing we have to do when solving a question like this, first write out the parameters. So we have velocity of 4, initial velocity, we write u, 44 meters per second, you write the 44 meters per second like this, so that when solving you know the equation to use. So the next thing is that what? And acceleration of what? This acceleration is what? Minus 4 meters per second square. This kind of acceleration is what? Deceleration, because and it is what? Negative acceleration. This is coming down. So its velocity after 10 seconds is, so we are asked to look for what? The final velocity and given the time 10 seconds. So the final velocity we are looking for. So now look at this thing very well. You'll find out that we have u, we have u, we have a, we have a, we have v, we have v. So you already know that this equation will be using this question will be using this equation. So now start substituting the value. We have v will now be equal to u. This 44 meter per second. Write the 44 plus our a is what? Minus 4. Out of our t, we have 10. So now 44 plus into bracket what? 4 times this minus 4 times 10. Have 44 plus into bracket minus 14. Now have 44 minus 14. Plus times minus minus. So we now have what? 4. So our v will now be what? So the final velocity will now be what? 44 minus that's 4 meter per second. So example 2. A body accelerates uniformly from rest. You know that from rest our u will be what? 0. At the rate of 3 meter per second square. Look at this. 3 meter per second square. That's acceleration. So our acceleration is what? 3. For 8 seconds, the time is what? 8. So, and we're asked to calculate the distance covered by the body during acceleration. So we are asked to calculate s. So from this, we can know our formula. We have what? S u a t. So we can use this formula. Ut plus 1 over 2 at square. So inserting the value, we now have s equals to, what's our u? 0. Multiply by this t, 8 plus 1 over 2, what's our a? Times 3 times our t, what? 8 square. So here we have, this one is what? 0. We now have what? 3 times 64 over 2, right? So 2, here we have what? 3 times 3, we have what? 3, we have 4 here. So our final answer will be what? 96. 3 times 34, we have what? 96. 96 what? Meter. So this is the last question. A body moving with uniform velocity of 3 meters per second is brought to rest. Know that when an object is going to rest, the final velocity will be what? 0. So moving with uniform velocity, this is it, which is what? 3 meters per second, is brought to rest by a constant force after traveling 15 meters, a distance of what? 15 meters. You write the distance there as 15, right? So we are asked and calculate the acceleration. So we are asked to calculate the acceleration a. So now from this, you know the formula. V square equals u square plus what? 2as. From this, you can make a subject formula and get your answer, or you can do it the other way. So by inserting the value and get there. So let's make a the subject of formula. We now have what? V square minus u square, so equals 2as. So dividing both sides by 2s. So now have 2s here. So our a now will be what? V square minus u square over 2s. So making a the subject formula will make our answer easier. So we now have a equals to, what's our v? 0 square minus our u square, 3 square, over, what's our s? 15. So we now have A will now be equal to minus 9 over 30. That's what 3 in this, we have 3 over what, 3 in this 10. So our acceleration will now be what? Minus 0.3 meter per second square. Don't forget your unit. It is very important in physics. So this is our final answer. So this negative sign means the what? The acceleration is what? Negative acceleration, that is, it is deceleration, and it is what? Rapid retardation. Thanks for watching. Don't forget to click on the subscribe button, share my videos with friends. Thank you. Please subscribe, like, and also comment.